I'm showing the top of the hour, so we're going to get started. I'd like to welcome everyone, and I hope you're all having a good day so far. The focus of this presentation is on ways to build recreational trails for walking, horse riding, and light vehicle use, as well as different methods for stabilizing embankments near trails. Oops. I'm your host, Corey Schneider, Business Development Manager with Presto Geo Systems. I've been with Presto for 15 years, providing technical assistance and site support for our entire product line. We are located in Wisconsin and manufacture erosion control, stormwater management, and porous pavement products that are used all over the United States and the world. We sell through an experienced distribution network that can provide local assistance on all of your projects. I have everyone muted now, so if you have questions during the presentation, please type them in the question window and I will answer them at the end. Here are the things. Excuse me, I'm having some technical difficulties advancing the slides here. Let me get this thing back on track. Got it all figured out. I apologize for that. Here are the things I hope you get out of today's presentation. Understand how to properly build trails to reduce the impact to the surroundings, how different trail users can affect the design, how to build through wetlands or other environmentally sensitive areas, and which products are most applicable for unique conditions that may be encountered. We're also going to touch on wall and slope design to ensure that embankments along trails remain stable. First, a little background on Presto. We worked with the Army Corps of Engineers to develop Geocell technology in the late 70s and have been innovating ever since. Our products have been used in over 200 countries and in every state in the US. And we do go beyond simply providing a product. We have a lot of design and construction resources available on our website. We've got experienced engineers on staff that allow us to provide free project evaluations to you for any project where you are considering using GEOWEB. And we'll also provide contractor support to make sure the installations go in not only correctly, but also as efficiently as possible. And as I mentioned, we sell through distribution, so we can provide local support through our distributors for any project that you're considering using the GEOWEB material. We basically operate in 3 product areas. We've got soil stabilization using our GEOWEB Geocells, which can be used for load support, slope and channel protection, and building green retaining walls. We've got porous pavements, both vegetated and aggregate solutions, and we also have lightweight reusable construction mats. Today we will cover some of the GEOWEB solutions, as well as our aggregate porous pavement product and a few of our construction mats. As an aside, I just want to make you aware that Presto has been a member of the Professional Trail Builders Association since 2019, and we actively attend trade shows and conferences pertaining to trail building. We are always looking for ways to build better trails, as well as getting the word out on our solutions. One important thing to keep in mind as we go through this webinar: the trails that are made with our products are all considered permeable trails. That is, there is no impermeable paved surface being placed. The final surface is going to be a stone or sand material. This lessens the environmental impact of the trail, reduces the amount of heavy equipment required for installation, often in difficult to reach locations, and improves the overall cost and speed of the project. We'll begin with what makes a good trail. The first aspect of the design is the reinforcement of the trail area. Especially when the trail moves through sensitive areas, keeping the path intact is how you keep people away from damaging vegetation or getting lost while wandering. The trail needs to be clearly delineated and needs to be reinforced enough to stay in place over time. Using products specifically designed to act as the reinforcement of the soil or stone means the trail will last longer and will not encroach on the surrounding environment. The next key to a well-designed trail is drainage. Ponding water can ruin a trail surface, and water that runs off the trail into unreinforced areas can scour and damage those areas. As I mentioned, all the products from Presto are considered permeable, and it is precisely for this reason. By keeping the surface permeable, the water infiltrates at the point of contact right when it hits the trail. The water can then permeate down through the product and into the subgrade, entering the groundwater system. The water won't pond at the surface, and it won't run off or collect outside the reinforced areas. This keeps the trail in the same condition no matter the weather, so there won't be any flaws or failures created below the surface that you can't see. The last thing to consider when designing a trail is how to confine the surface. Loose aggregate, stone, or sand is easily moved under shoes, hooves, tires, and water, leading to ruts, holes, and generally damaged trail areas. When the trail surface is damaged, people are going to want to move around the damage, leading them off the trail and into unprotected areas, potentially disturbing sensitive environments. Keeping the surface in place is an important feature of the products from Presto. When the stone or sand is properly held in place, ruts cannot form and the material can't be washed away. This greatly reduces the amount of maintenance required because the trail surfaces aren't degrading. The first product we'll look at is the GEOWEB three-dimensional soil confinement system. This is a geocell, which may be a term you have heard of before. It's similar to a geogrid, but is three-dimensional, so it has depth to provide true confinement and can be used in a wider variety of applications. The GEOWEB system consists of two main components: cell size and cell depth. The cells come in three sizes: approximately 8" by 10" 11" by 12", and 18" by 20". Each one of these cell sizes can come in 3, 4, 6, 8, or 12" depth. The combination of cell size and depth depends on the project details and loading requirements, but generally trails will use a 4 or 6" depth and a small or medium-sized cell. The seam strength is very important to the function of a geocell. The stronger the seam strength, the better designed the geocell is. A strong seam allows for a heavier infill material, steeper and taller slopes, and better lifetime performance. The strength of the panel material, in our case high-density polyethylene, is also critical to the strength and performance of the geocell system. Here you can see a typical GEOWEB panel. It comes tri-folded and palletized. Each section has a nominal width of 8.5 feet with lengths up to 58 feet. The panels are flexible, opening like an accordion, so they can follow the natural contours of the work site without being confined to a rigid set of dimensions. Here you can see our standard performance and material specification summary. As you can see, there's a lot of information packed into the standard spec. We don't have time to go through everything, but I at least wanted to provide you with a sense of what a typical GeoCell product spec should look like. You'll note that it contains a lot of detail on key material properties, including weld strength and ESCR, or environmental stress crack resistance. And just a general note, when reviewing product spec sheets for GeoCells, or any geosynthetic product for that matter, you'll want to pay close attention to any disclaimer language a product provider tries to sneak into the fine print, usually at the bottom of the page. Recently, we've noticed a concerning trend where low-end product providers present performance data that appears to equal industry accepted standards on the surface, but then they add disclaimer language in the fine print at the bottom stating that their specifications are subject to change without notice, or the information shown is for general purposes and not intended for design. Just a heads up to watch out for this type of trap, especially if you get hit with a request from a contractor on one of your projects to evaluate a substitute product. Our spec sheet contains no disclaimers, and we stand behind our numbers so you can deliver certainty in the solution as you build with materials you can trust. The GEOWEB system, again, is a three-dimensional cellular confinement system, meaning that the GEOWEB panels have individual cells that are filled with an infill material that ultimately makes the final surface of the trail. By confining the infill material, the system distributes the loads and prevents rutting, and the cells keep the infill in place so that it doesn't wash away from stormwater runoff or move with traffic. The surface of the trail is going to be stable no matter what infill is chosen and require very minimal maintenance for the lifetime of the project. Let's look at some different options for building stable trails with the GEOWEB system. Walk, run, and cycle trails are meant for people, small animals such as dogs, and bicycles only. This type of trail is not meant for equestrian use. These are the most common type of trails and can go along shorelines, through urban areas, or through forests or parks. The flexibility of the GEOWEB panels allows for smooth, natural-looking curves. The panels can be held open with stakes, as shown here, but those stakes are generally not permanent. They can be removed once the panels are fully filled. The panels can be laid either along the length or width of the trail. They are easily field cut with a saw or landscape shears and are securely attached together. No matter the dimensions, there will be little waste as panels can be pieced together in nearly any configuration. This is the finished trail surface using a local granite aggregate and allowing vegetation on both sides. The trail is clearly delineated and meets up with existing paved trails in the distance. The GEOWEB panels will keep the trail in place and level, minimizing surface erosion and potential runoff of contaminants into the adjacent water. This path used granite, but any type of stone is going to be acceptable as an infill material, with the only limitations being it should be angular and have a maximum particle size of about 1/3 the cell depth. So you can use what is local to your area without needing to truck in expensive engineered aggregate. As I said, it's easy to field cut the GEOWEB panels to accommodate the trail dimensions, even rather narrow trails like this one between a road and protected wetland. By having the GEOWEB panels create the trail, water runoff from the road won't wash dirt into the wetlands because the water will be able to infiltrate through the permeable GEOWEB surface, keeping the dirt surface in place for a nice jogging path. Paths through neighborhoods or urban areas can augment or replace traditional sidewalks in places where drainage is a concern. Replacing broken and ugly concrete sidewalks with gravel surface paths allows for flexibility in design and aesthetics and will improve the safety of the walkway for pedestrians. These types of trails are good for any typical sidewalk traffic, but can also be designed to support cars or trucks. A 3 or 4 man crew can install about 1,500 square feet of GEOWEB panels per hour, including laying a geotextile fabric and infilling the panels. The geotextile helps to create a separation layer between the natural subgrade and the infill material, which is especially important in areas with very soft subgrades such as a wet clay. The flexible nature of the GEOWEB panels allow it to conform to hills and dips in the path and allows the system to be pitched to one side if needed. Because GEOWEB gives additional strength to the infill material through confinement, cross sections can be cut in half or more, reducing excavation, aggregate, and maintenance costs. We recommend overfilling the GEOWEB panels slightly when installing so that there is a wear surface over the panels and the plastic is not visible. This surface will become naturally compacted over time based on the trail usage. Having the panels slightly overfilled helps protect the GEOWEB material from vehicle tires or other potential damage. Equestrian trails are next, and they have some different requirements than walking paths. Equestrian trails have to be hardy enough to stand up to horseshoes while remaining smooth enough to avoid damaging their hooves. Horseshoes can pick up a surprising amount of dirt with each step, and with their heavy concentrated point loading can cause fast deterioration of the trail. If the trail is designed to withstand horse traffic, it is more than sufficient to handle hiking, biking, and small motorized vehicles. A GEOWEB trail system was utilized for erosion control for these equestrian trails. The gravel surface is resistant to rutting, and the 1-inch stone size is easy for the horses to walk over. This aggregate path will not get muddy or create sinkholes, so the surface will remain ready for use even after rain or heavy use. Having a well-defined path also helps prevent damage to areas off the trail, and using the GEOWEB system allows for inclusion of natural markers, such as the large boulders we see here on both sides of the system. Now we're going to walk through a case study for a shoreline trail in the Colony, Texas. This project was a multi-use trail along the shoreline of a lake. The trail will see pedestrians, bikes, small vehicles, and potentially equestrian traffic. The client, the city of the Colony, wanted to follow the natural contours of the shoreline, which the flexible GEOWEB panels can easily handle. There was a concern about the potential for uplift under the system due to the very high water table and lake level fluctuations, so additional steps were taken to prevent this from occurring. A series of polyester tendons were run through the GEOWEB panels and anchored multiple times per panel. The tendons, in conjunction with the final infill stone material, prevent the GEOWEB system from lifting and deforming due to groundwater pressures. This is a good practice in wet environments with potentially saturated soils. A well-graded decomposed granite was chosen as the infill material as it was readily available in the area. Using local materials is encouraged, though any type of stone is acceptable as long as it is angular and allows good drainage. This means that you are going to want stone with limited fines so that water can percolate through. If the water can't infiltrate, you will get ponding at the surface, similar to a paved surface such as asphalt. So you want to make sure your infill material avoids this problem. And you should keep in mind that this material is going to be your final surface, so aesthetics may be a factor in choosing the material. Once the GEOWEB panels were installed, the infill was placed with a standard front end loader and then raked by hand to ensure all the cells were fully filled. The material should be placed on the outside of the panels as needed to match the final grade and meet up with the unexcavated areas. For ease of construction, you can drive your vehicles and equipment on the GEOWEB panels as soon as they are filled, right up to the limits of the filled area if necessary, so you don't have to wait for the entire system to be filled before using it. This can help minimize the impact of construction on the area, since you won't need to create access lanes or clear out excess vegetation on the sides. A small smooth-barreled roller compactor finishes off the job. This is where having the wearing surface of overfilled material mentioned earlier comes into play. The compactor isn't driving directly on the GEOWEB panels, and you can easily visually confirm that no cell is underfilled. Again, the stone infill should have minimal fines. Generally, less than 10% is ideal. Avoiding fines in your stone allows the system to stay permeable and not get clogged. Trails built with the GEOWEB system are a great example of green infrastructure by not disrupting the water cycle or impacting the groundwater flow. No additional stormwater infrastructure is needed when the trail surface is permeable, so there is minimal impact on the environment around the trail. Here we can see the nice clean trail created using GEOWEB, allowing for most uses without having to worry about needing constant maintenance. The path is clearly delineated while maintaining a natural look that people won't mind seeing in their backyards. A few months after installation, there was a massive rainfall event, over 7 inches in a 3-hour period, which can be incredibly damaging both during and after the storm. Several portions of the trail were flooded to the point of standing water at the surface on and around the GEOWEB protected areas. But thanks to the GEOWEB system and the extra precautions such as the tendon system that was used, the trail was not washed away as you might expect from an unprotected gravel trail. It was still usable, allowing maintenance workers access to the damaged areas for inspection and repair. No repair was needed to the GEOWEB system, and once the water was able to infiltrate, the trail was as good as new. When there is such a large rainfall event, the ground becomes saturated and doesn't allow water to infiltrate, giving it no choice but to stay at the surface and become sheet runoff. The GEOWEB system protects the trail surface against erosion when this happens, with the cell walls functioning as a series of check dams, keeping the infill confined within the individual cells. Then, when it is able, the water can infiltrate into the ground and the trail is still in good shape. On to another project. In the spring of 2018, several storms violently swept through areas along southern Maine's coastline, devastating the beaches and trails of Fort Foster, a town-owned park in Maine. As you can see from these photos, the trails and maintenance roads were washed out. To reconstruct the washed out recreational trail and maintenance road, 6-inch depth GEOWEB panels were installed at the site and infilled with 1-inch crushed aggregate. There were sections of the trails that sloped down to the beach areas. To stabilize the 2-to-1 slope areas down to the beaches, 4-inch depth GEOWEB sections were secured to the face of the slope. A dead man tendon and atra tendon clip system was used. Then the GEOWEB was filled with aggregate and covered with large riprap. By using the GEOWEB system, the park was able to armor the maintenance road, recreational trail, and slopes from future storm events. Here's a before and after photo of one area of the trails. And here we have a photo of one of the finished Shoreline trails a few months after completion. Since its original installation in 2018, the GEOWEB load support and shoreline protection system continues to perform as designed, allowing the community to once again enjoy the trail system and local beaches. One of the biggest questions we get is about cost. No surprise there, especially if this is a new technology for you or your area. Having an idea of how much the GEOWEB system costs compared with other stabilization techniques is very important. So here we have a basic comparison for the GEOWEB system for a load support application, in this case a gravel surface road. This comparison shows the difference in both price and cross-section depth for an aggregate only, unreinforced section, a section using geogrids and geotextiles, and then two sections showing the use of the GEOWEB system, one with aggregate and one with salvaged on-site materials as the infill. You can see the GEOWEB system is both thinner and less expensive than the other methods, significantly so when on-site material is utilized. In fact, you have a 40% savings compared to the geogrid geotextile section, which does not allow for the use of most salvage or on-site materials, as high friction angle, well-graded material is required with the use of grids and textiles. Of course, your aggregate costs and distance to quarries may vary, but this does give you a general idea of the savings that can be achieved. Now we're going to move away from the GEOWEB system, and our next option illustrates similar confinement of infill, but within a rigid paver structure known as GEOPAVE. Unlike the GEOWEB material, which is typically 4 or 6 inches deep for trails, GEOPAVE units are 2 inches deep and made from recycled high-density polyethylene. The GEOPAVE units have these rigid paver characteristics with specific features needed for performance with aggregate infill. The main one I want to highlight is the monolithic mesh bottom. This is a molded in place mesh on the underside of the paver unit. This mesh keeps the stone infill from migrating under the unit, and the integrated nature assists in the overall rigidity of the paver unit. The lattice bottom spreads the load similar to a snowshoe, so the wheel loads do not create ruts. GEOPAVE units are locked together with a connection device to create a fully integrated, contiguous pavement that is highly resistant to traffic stresses. GEOPAVE was designed using a finite element analysis and will not lift up over time as seen with other systems. As I mentioned, the GEOPAVE unit is only 2 inches deep, which can be a real asset if the project requires a thin cross section due to buried utilities or high excavation costs. We'll now look at a few project examples. This project is an access trail for walking down to a swimming area on a lake. The walkway had to be ADA compliant so that everyone could use it. It was also important that the trail help reduce runoff into the lake, so the permeable nature of the GEOPAVE system was critical. You can see the eroded trail before stabilization, both the trail surface and the surrounding areas, and the new trail area on the right stabilized with GEOPAVE. The protected system will help prevent erosion from stormwater runoff and be a smoother surface for walking on for visitors. This is another trail in a wetlands area. Here, the GEOPAVE units were placed directly on the subgrade, but a geotextile separator fabric and a base layer of aggregate underneath the panels can be incorporated to support heavier loads or add additional detention. No matter the section, the entire system creates a flat, stable surface and supports the anticipated loads. The same principles that we discussed with the GEOWEB system apply here as well. By using an open graded aggregate stone with minimal fines, the water can infiltrate at the point of contact, reducing surface runoff, and the individual cells can find the aggregate, preventing rutting and washout of the stone for a stable walking surface. A major concern here was protecting sensitive tree roots from impact damage. The GEOPAVE units are a great way to provide tree root protection by creating a bridge over the roots, so there is no direct contact from vehicle or pedestrian loads that could harm the trees. This bridge lasts the lifetime of the GEOPAVE trail and allows the trees to grow unimpeded. One of the great things about building trails with the GEOWEB or GEOPAVE system is the amount of choice you have over the final look of the system. 2 rock colors were chosen at this site to delineate the parking from the walkways. A light colored crushed limestone was used for the parking areas, and a contrasting reddish brown buckshot crushed aggregate for the walkways. Additional delineation, such as concrete parking stops or the snap delineators that Presto manufactures, can also be included to help create a sense of separation within the overall GEOPAVE system. This project ultimately earned LEED Gold for all of the low impact structure and landscape elements. Protecting the local watershed was the primary reason for the inclusion of permeable parking and walkways utilizing the GEOPAVE system. These pavements also perform as natural on-site stormwater detention, storing water in the base for natural percolation without the need for a large isolated detention pond, which would have been an unattractive nuisance on site. The GEOPAVE units come in 20 by 40 inch panels covering about 5.4 square feet, but they can easily be field cut or staggered to accommodate curves, so you are not locked into a linear path. The system was a great choice for this project with a quick and easy installation, the ability to allow water to flow through the system and not run off into the pond, and because it provided a smooth, clean surface for walking. The standard GEOPAVE units are black, but a tan GEOPAVE is an option that allows natural blending with light colored stone. Again, the options available for the final design of the trails are what make using this system so versatile and a great choice for any project. The last option for trail surfaces is the GeoTerra system, which are construction mats that are strong yet lightweight and don't require any fill. Because no fill is required, they are perfect for areas where infill resources are scarce. Because there is no fill material, GeoTerra trails won't kill the existing vegetation they are placed over. They are open on the top and bottom and allow for vegetation to grow through them for as long as they are in place, which is essential for minimizing environmental impacts on pathways. The units cover approximately 5 square feet each and can be connected to cover a larger area as needed. The mats are strong enough to support heavy vehicle and construction traffic loads and have enough flexural strength to bridge soft soils without warping or cracking. The units are connected with strong metal connectors to essentially form a floating road through wetlands with very soft soils. The connected mat system distributes loading across the pavement, minimizing potential for rutting or sinking in soft, muddy soils. In some areas of Alaska, hundreds of miles of ATV trails cut across wetlands and stream beds, causing extensive damage to natural preserves. ATV riders can cause the loss of vegetated cover and habitat values. GeoTerra mats offer a great solution for low impact access in these wet and environmentally sensitive areas. The preferred method is to place the units across the entire trail width, but in some cases, just in the wheel paths is acceptable. As planned, indigenous grasses regenerated through the permeable open-celled GeoTerra mats, ultimately semi-camouflaging the product with the natural environment and protecting the vegetation from damage. In this case, the system ultimately ended up as a permanent structure, and the GeoTerra mats will be able to last for as long as needed. The last section is now going to pivot from the flat surface of the trail to the embankments that may be alongside or near the trail. Green walls can help create the space for trails to run through and work with permeable trails to allow water flow and promote vegetation. The same GEOWEB geocell technology that creates the trail surface can also be adapted to create retaining walls, such as this vegetated levee. The GEOWEB panels are stacked vertically on top of one another to create the wall, allowing for more horizontal space for the trail to be placed. The primary benefit of the GEOWEB wall is to create a stable, natural living structure with vegetation for aesthetic appeal. The open front fascia allows rainwater to infiltrate. The wall structure can also absorb some runoff from the top of the wall, such as from walking trails. While vegetated walls are most common, aggregate-filled walls are also possible. Using the same open graded stone we have been talking about, water can infiltrate through the wall so there isn't runoff onto your road or trail. An aggregate wall may be useful when you don't want to worry about maintaining vegetation in an area, such as an emergency response space, or in areas where vegetation is difficult to establish. The walls are designed as either gravity or reinforced walls in the same way as mechanically stabilized earth or MSE wall systems. An advantage they have over MSE block walls is flexibility in poor soil conditions. Their relatively lightweight and flexible nature allows them to tolerate reasonable differential settlement very well. Another advantage over traditional walls, such as gabion basket walls, is the relatively shallow embedment depth of the wall and the ability to create a very steep wall face, as steep as 80 degrees. Walls can be built in channels with limited space, such as through neighborhoods, without the need for heavy unloading delivery vehicles. The steep side slopes of the channel mean that the horizontal footprint is much smaller than if the side slopes needed to be shallower. The small required construction footprint is well received by residents of neighborhood projects. It's always necessary to consider live and dead loads that the wall will experience, especially when placed near trails or roads. Dead loads would be things like buildings or soil slopes above the wall, while live loads are for construction traffic and long-term vehicle traffic. When possible, the load should be placed away from the edge of the wall or fascia, but if not possible, the design will need to be robust enough to support and withstand both live and dead loads. Having traffic barriers at the top of the wall, such as this wooden fence, will help keep the loads away from the GEOWEB system, which can help with the design. We'll now look at a vegetated retaining wall case study. This project was faced with having to retain soils in a very problematic soft soil area, but piling systems were expensive and they wanted to maintain the natural environment. Concrete and modular block walls were considered, but ultimately they chose the vegetated geocell wall for its natural aesthetics and lower cost. Here you can see the wall structure is constructed with a slight setback to allow for topsoil fill and vegetation in the front face. The backfill material is a good drainable aggregate. The wall can be seeded either by mixing the seeds in the soil before installation or by hydroseeding or broadcasting once installation is complete. As mentioned, the system's inherent ability to withstand some differential settlement in soft soil environments was extremely important at this site. The wall had varying heights along its length, which was also easily accommodated by the Geocell system. By using the Geocell wall, they didn't have to bring in invasive equipment such as augers or H-piles, speeding the installation process. Here's the completely vegetated wall. The horizontal terraces allow rainwater collection, helping to minimize runoff and erosion. Pretty much any type of grass or flowering vegetation will survive on these walls. So by using local vegetation, upkeep can be kept to a minimum. Presto offers a free software for designing GeoWeb retaining walls and slopes. It's available on our website, which is prestogeo.com, and can be used by engineers and designers to determine if the GeoWeb system is appropriate for your projects. There are a lot of resources on the website on how to use and interpret the software, but we are always happy to help with questions or recommendations. So far, we've looked at trail surface construction and vegetated retaining walls. GeoWeb can also be used for erosion protection in a superficial manner. This is a good way to protect slopes against erosion when the slope is shallower than what would be required for a retaining wall and globally stable, around 60 degrees or shallower. If there are questions about this type of application, we are happy to talk through it. There are three main infill types for slopes, depending on the type of protection needed: topsoil, aggregates and granular materials, as well as concrete. We will focus on topsoil and vegetation infill, as that is typically what is selected in trail applications to keep things looking as natural as possible. Here's a simplified diagram showing how the different system components interact with the GeoWeb to form a complete system. We'll talk about each of these components next. To begin, we have our slope with some standard dimensions. The first thing to go down is the geosynthetic layer, which can be a geotextile, geomembrane, geogrid, or any similar product. These aren't always required, and we typically try to stay away from them in vegetated applications, but we can make recommendations based on project details. Then the GeoWeb is put in place. Note how the GeoWeb has a horizontal turn near the top of the slope. This is important for crest anchorage and erosion control. We have two options for anchoring. One is using stakes or anchors. These are placed mid-slope and at the crest. The number and spacing of stakes is project dependent. And the other option is to use tendons and a dead man, with a dead man being a buried pipe, concrete anchor, or earth or rock anchors at the crest. The GeoWeb is then filled with the desired infill material, and if vegetated, an erosion control blanket or hydroseeding is used until vegetation is established. The ATRA key is the first component for a completely integrated system, connecting each individual panel of GeoWeb into a single web that covers the slope. It allows for faster installation of the GeoWeb and will last the lifetime of the project, ensuring that the slope is protected and that the GeoWeb system will not fail under anticipated loads. The specific engineering values of the ATRA key will ensure that the system holds up to loading over time without the corrosion seen in staples or the failure of underperforming cable tie systems. As slope angle increases, the driving force of the infill material exceeds the available frictional resisting force, and additional anchorage is required. The ATRA anchors, which are our ATRA clips on top of number 4 rebar, hold the GeoWeb to the slope and penetrate into the ground. If corrosion resistance is required due to project conditions, Presto has an HDPE ATRA speed stake that is designed to work with the GeoWeb. For long, steep slopes where the native soil is highly erodible, or over a surface that cannot be punctured, such as a geomembrane, tendons can be used. The ATRA tendon clips transfer the load from heavy infill material to the tendons and crest anchorage system. Only the Atra tendon clip is specifically designed to fully transfer safely and securely the forces placed upon the geocell. Every accessory and every feature has been designed and tested to specifically work together so that we go from problem to design to construction solution with a system where the modeling replicates the real world forces. Now we'll take a very quick look at a couple of slope protection projects associated with trails. The American Tobacco Trail is a 20-mile rails to trails project running from Durham County to Chatham County in North Carolina. This slope had to be reconstructed after it was excavated in conjunction with the replacement of a culvert. After the culvert was replaced, the slope was regraded to its original 1.3 to 1 slope, and it needed to be revegetated. The GEOWEB slope protection system proved to be the perfect solution. Another great example of using GEOWEB for slope protection on a trail is the Lance Armstrong Bikeway in downtown Austin, Texas. And as we can see from this photo, the cells were filled with soil and then small plants were actually placed into the individual cells. In summary, Presto Geosystems offers GEOWEB, GEOPAVE, and GeoTerra that can meet any trail design needs, as well as GEOWEB for earth retention and slope protection near trails. Each product is designed to protect the surrounding environment while offering a low maintenance surface that won't wash away during heavy rain events. We offer a complete solution, including connections and anchoring options. Part of our complete solution is our technical assistance. As mentioned, we provide free project design evaluations. The form is on our website. You can fill it out with as much information as you have, including attaching documents such as geotechnical reports, and then it will go to our engineering staff. Generally within 3 business days and many times faster, we provide a complete design evaluation, including infill recommendations and anchorage requirements. We will work with you to get you the best design for your project. We have made it faster and easier for you to obtain your PDH certificates now. With our webinar dashboard, you can easily view our library of webinars and download PDH certificates for on-demand webinars completed. Your webinar dashboard will keep a record of on-demand webinars completed along with PDHs learned. Please note that certificates for live webinars are managed separately from the on-demand webinar dashboard, so you won't find your certificate from today in there, but you will receive an email from GoToWebinar within the next 24 hours containing a download link to obtain your PDH certificate. In 2 or 3 days, you will also receive a separate email from Presto Geosystems with more information about accessing the on-demand webinar dashboard with other helpful resources. If you do not receive either of the previously mentioned emails, please check your spam folders. Here's my contact info. I do want to thank you for attending and remind you that you can send questions to us at any time to info@prestogeo.com or directly to me at the email listed here. Go to prestogeo.com for a wealth of information, and don't forget to view our YouTube videos found by clicking on the YouTube icon in the upper right-hand corner of our webpage. I'll answer questions next, but if you do have a question that I don't get to or you think of a question later, you can respond to the follow-up email and we'll be happy to answer your questions and help with other project recommendations. So now I'm going to take a look at the question box and see what we've got in here. First one is, when overfilling the cells for a trail, do you recommend compacting the infill material after filling to help reduce settlement? Yes, we do recommend compaction. So generally speaking, we would recommend that you overfill initially about 2 inches and then run a roller compactor over the top, and you'll generally end up with about 1 inch or so of a wearing surface at the end. I do want to point out that we definitely want to stay away from vibratory compaction, as that vibration can sometimes work the material down underneath the web and cause the web to lift up. On steeper slopes, do you recommend using a mechanical binder such as polymeric sand? You certainly can do that. It really is going to depend on the type of infill as well as the slope angles. But a lot of times just hydroseeding it is really all we need to do. How were Army Corps permits obtained for surface trails in Alaska wetlands? Was there resistance to allowing this material? We didn't actually participate in the permitting process. Most of the work we do up there is with the native villages, and they are generally handling the permitting. But as far as I heard, because the geoterra mats were left empty, there was very little resistance to allowing them. Next one. Assuming you had to cross wetlands to get to your construction site, would coordination with the Corps still be required to obtain their approval prior to using geoterra mats on wetlands during construction? Yeah, I mean, anytime you're crossing wetlands, you do need to get the Corps involved. Again, certainly if you do want to bring in any fill, then it becomes more problematic, but many times you could just use our geoterra mats as temporary construction access over those wetlands that you aren't going to leave a permanent trail in. So the geoterra mats are both temporary and permanent. Do finer materials choke off the coarse grained surfaces and cause issues with drainage over time? Yeah, they certainly can. That is why we do want to limit the amount of fines to 10%. And of course, you want to do everything you can to avoid bringing those fine materials in with whatever traffic the trails may see. Will your products work well for steeper trails, such as areas where the slopes may be 18%? Yeah, once we get over about 15%, we'll then use permanent stake anchorage to make sure those trails don't move over time. Do you recommend graded aggregates versus clean stone? It really depends what your most important concern is. The clean stone, of course, is going to allow for better drainage long term. The graded aggregates might lock up a little better in cells and give you a firmer surface. So you kind of have to balance what you're trying to accomplish when picking the infill type. GeoPave with grid exposed appears to be a tripping hazard or point for erodibility. Does this meet ADA? It does meet ADA, and as long as the cells are filled, you do not have any tripping hazards. How will the GeoCell prevent tree root lifting and causing trip hazards? It really doesn't prevent the tree roots from lifting. If you are right next to a tree root, that area is just going to have to be you're going to have to keep an eye on those areas to make sure that you don't create any trip hazards long term. And that looks to be the end of the questions. So looks like we're completed here in 54 minutes. Again, I want to thank everyone for attending. If you do have other questions, you can send them to me or info@prestogeo.com, and we'll definitely respond to any questions you might have. Take care and have a good rest of your day.